This lesson has two parts. The first is about measures of central tendency, and the second part is about quantiles. For measures of central tendency or measures of averages, in statistics, an average is a single value that is used to represent an entire data set. We have three of these measures of averages. We have the mean, the median, and the mode. These three are used in different situations depending on the given data set. There are situations where the mean is more appropriate than either the median or the mode. There are other cases where the median is more appropriate or the mode is more appropriate. We will discuss which measure of average is more appropriate for what situation in another lesson, because in this one, we will simply talk about how to find the mean, the median, and the mode of a given data set. And we will take up two examples, one where the data set has an even number of values, and another one where the data set has an odd number of values. Before we look at these examples, please note that we use x bar with a lowercase x to represent the sample mean and the lowercase Greek letter mu to represent the population mean. The mean, median, and the mode, we don't have special symbols for them. These are the two problems that we will discuss, and we have two data sets, and we will find the mean, the median, and the mode of each of them. We will also assume that each data set is a sample data set and not a population data set. Let's take example 1. Here we have the number of airplanes flying into an airstrip over a 15-day period. Let's start with finding the median. When finding the median, the first thing that we need to do is to arrange the values from least to greatest. So here we have 2 zeros, 2 twos, 2 threes, 3 fours, 3 fives, we have 1 6, and 2 sevens. Now note that this data set has 15 values. So 15 values. We use n to represent the number of values in a data set. So in this case, we have n equals 15. When the values in a data set are arranged from least to greatest, the one in the middle is the median. Because we only have 15 values, it's easy to spot that the 8th value will be the middle term. Now, to show this in a calculation, because we're looking for the middle value, we simply divide 15 by 2, and that would be 7.5. The answer 7.5 here means that the middle value is after 7. In other words, in this case, the median is the 8th value. And if we look at our list here, we have 2, 4, 6, 8. It is this one. So the median is 4. So with 4 in the middle, we have 7 values here and 7 values here. So using the median as a measure of average in this case, the average number of airplanes flying into the airstrip is 4. Now next, let's find the mode. The mode is simply the value that appears the most number of times. In this case, we see that 4 appears 3 times and 5 also appears 3 times. So we actually have two modes here, 4 and 5. When a data set has two modes, we say that the data set is a bimodal data set. As you know, the prefix by here means 2. Next, let's find the mean. So the mean is our usual concept of average. This is where we add all the values in the data set and divide it by the number of values there are. We usually see the formula for the mean written as the mean x bar, sample mean x bar, is equal to the sum of all x sub I from I equals 1 to n all over n, where n stands for the number of values in your data set. And if you remember your summation notation, the numerator in this formula simply means the sum of all values. And also, since we are adding all the values anyway, the limits on the summation notation are usually omitted. So the formula is also sometimes written as x bar is equal to simply the sum of all x sub I all over n. So the sum of all the values here is 57 divided by, there are 15 values, that is 3.8, which means that the average number of planes or airplanes flying into the airstrip is about 4 airplanes. Let's have example 2. We have here the scores of students in a math quiz. Let's find the median first. Let's arrange the values from least to greatest. So we have 1 4, 2 5s, 2 6s, 3 7s, and 2 8s. This data set has 10 values. Again, because it's small, it's easy to see what the middle value is. But just to show the calculation, because we are looking for the middle value, we will have 10 divided by 2, and that's equal to 5. So this whole number result here means that there are 2 middle values, and in this case, it's the 5th and the 6th. When that happens, when you have 2 middle values, the median will be the average of those 2. So in this case, the median will be the 5th value plus the 6th value divided by 2. So if you look at our list, we have 2, 4, these are the 2 values. So the median will be 6 plus 7 divided by 2, or 6.5. For the mode, we see here that the number 7, so 7 appears the most number of times. So that will be our mode. So mode equals 7. In this case, we only have one mode, so this data set is called a unimodal data set. And as you know, the prefix uni here means 1. So that's why it's called unimodal. Next, for the mean, the sum of all values divided by n. If we add all the values here, we get 63 divided by 10 is 6.3. So that is your average score there. Now let's talk about quantiles. A quantile is a value that divides a distribution or a data set into equal parts. 3 examples of the quantiles are the quartile, decile, and percentile. So when the values of a data set are arranged from least to greatest, and you divide the values into 4 equal groups, the values that divide in the dividing values, they are called the quartiles. So the first one is called the first quartile, and we have the second quartile and the third quartile. Now notice here that the second quartile is actually the middle value of the entire distribution, so that is actually equivalent to the median. And similarly, if we divide the data set or the values in the data set into 10 equal parts, the divisions, each division is called a decile. So we will have, so this is decile 1, decile 2, decile 3, decile 4, decile 5, decile 6, 7, 8, and decile 9. In this case, the middle value is decile 5, so that is equivalent to quartile 2, which is equivalent to the median. Similarly, if we divide the arranged values into 100 equal parts, each division is a percentile. And so the middle value, the middle division divider will be P50. That will be equivalent to the median. And then this will be P25, which is equivalent to quartile 1. And here we will have P75, the 75th percentile, which is equivalent to quartile 3, and so on. Let's talk about the quartiles in more detail. As we have seen earlier, if we divide the distribution into 4 equal parts, we will have 3 dividers in between. We have the first quartile or quartile 1, the second quartile or quartile 2, and the third quartile or quartile 3. We use the symbol Q sub 1, Q sub 2, and Q sub 3 with uppercase Q in them. And we have the same symbol for whether we are using a sample or a population. Now, we will use the same data set that we used earlier, but this time we are going to look for the quartiles. Let's start with the first data set, and just like finding the median, the first step in finding the quartiles is arranging the data set into, or from least to greatest. One way of going about this is to find the second quartile first, which is equivalent to the median. So since we have 15 values here, so finding the second quartile is the same as finding the median. So we have 15 values divided by 2. It's 7.5. It means that we have the second quartile is the 8th value. And we've done this before. The 8th value would be 2, 4, 6, 8. It's that value, so it's equal to 4. Now, once we have the second quartile, the first quartile will simply be the middle of the first half. So 1, 2, 3. That's the first quartile. And the third quartile will be the middle of the second half. 1, 2, 3. This is the third quartile. So the first quartile Q1, Q sub 1, is 2, and the third quartile Q sub 3 is 5. There's another way of doing this, and you might find this more handy if the value of n is large. So since we are dividing the distribution into 4 equal parts to get Q1, and in this case we have 15 values, to get Q1, we get 1/4 of 15, and that would be 3.75, which means that the first quartile is after the third term. So Q sub 1 is the 4th term, or the 4th value. And in this case, it's 1, 2, 3, 4. This is a first quartile. So the second quartile is the second of the four divisions. So it's going to be 2/4 or 1/2 of 15, which is 7.5, which means that it is the
after the 7th term. So Q sub 2 after the 7th term, or the 7th value, is the 8th value. And in this case, it's 4, 5, 6, 7, 8. The second quartile is 4. The third quartile is the third divider, so it's 3/4 of the distribution. So 3/4 times 15 is, that is 11.25. So it means that the third quartile is after the 11th term. So Q sub 3 is the 12th term, or the 12th value. In this case, it's 8, 9, 10, 11, 12. So that's 5. So notice that we are getting exactly the same values as the values that we got in the first method. Now, how do we interpret our results? Remember that what we're talking about here is the number of airplanes that fly into an airstrip over a 15-day period. So really what we have here, the values that we have here, are the number of planes per day over 15 days. Also keep in mind that each group is 25% of the distribution. So what does Q1 equals 2 mean in this case? We could say that 2 or less airplanes fly into the airstrip about 25% of the time, while 2 or more airplanes fly into the airstrip about 75% of the time. Similarly, for Q2 equals 4, we could say that 4 or less airplanes fly into the airstrip about 50% of the time, while 4 or more fly about 50% of the time. And instead of 4 or less, we can say at most 4. And instead of saying 4 or more, we could say at least 4. For Q3 equals 5, we could say at most 5 airplanes fly into the airstrip about 75% of the time, while at least 5 fly about 25% of the time. Let's take another example, and let's arrange the values from least greatest. Then for Q1, since we have 10 values, let's get 1/4 of 10. That would be 2.5, which means that Q1 is after the second value, so it's the third value. So it's 1, 2, 3. This is Q1 equals 5. For Q2, we get 1/2 of 10 is equal to 5. So the whole number answer here means that there are 2 values. And in this case, it's going to be the 5th value and the 6th. So we just get the average of those two. So the 5th plus the 6th value divided by 2. And in this case, it's 4, 5. It's between these two. That's our Q2. So that's 6 plus 7 divided by 2, 6.5. That is our second quartile. Lastly, for Q3, we get 3/4 times 10, which is 7.5, which means that Q3 is after the 7th value, so that would be the 8th value, and it's 7. So how do we interpret our results? Let's take Q1 as an example. Now remember that we are talking about here the scores of students in a math quiz. So in this case, Q1 equals 5. We could say 25% of the students who took the test got a score of at most 5, while 75% of the students got a score of at least 5. And lastly, also please note that the first quartile is also sometimes known as the lower quartile, while the third quartile is also called the upper quartile.